So good morning, we're going to go over 7.2 notes, which is multiplying powers with the same base. So we went over the theory yesterday, but we didn't go into practice. So when multiplying powers with the same base, you add exponents. So this is true for numerical and algebraic expressions. So what is each expression written as a single power? Now, because this is the same base, we can actually just go ahead and rewrite it all with the exact same base and then just add up the powers. So it would be the base of 3 to the power of 4 plus 2 plus 3, which is 10. Sorry, not 10. 9. 3 to the power of 9. Now, all three powers have the same base, so this expression can be written as a single power by adding the exponents, which is just what we did. So 3 to the power of 9. So all powers have the same base. Add the exponents. You can simplify the exponents. Now, 3 to the power of 4 represents 4 factors of 3, or 3 squared represents 2 factors of 3. And 3 cubed represents 3 factors of 3. This is a total of 9 factors of 3, so the answer is reasonable. So if we were to do 3 to the 4th power, it's going to be 3 times 3 times 3 times 3. We have 3 to the power of 2, which is going to be 2 more 3s, and then 3 to the power of 3 is 3 more 3s. 1, 2, 3. So if you actually end up counting them, you get 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where the 9 comes from. That's why adding the exponents of the same base works. Now, if you follow the rule, you don't have to expand them to prove it, but it is good to understand how it works. So even when the expression contains negative or rational exponents, the exponents can be added when the bases are the same in a product of powers. So for example, here we have, for example, b, 11 to the negative 3 times 11 to the 4th times 11 to the negative 9. You're going to add them just the same way, negative 3 plus 4 plus negative 5, as they do right here. And we end up with a negative 4. That's fine. We can be left with a negative exponent. Now, to fully simplify, you would write 1 over 11 over 4. But if you're adding them, getting a negative exponent on the top, it is 100% okay. You just have to flip it at the very end to get the final answer. Also, you may have bases with exponents that are fractions. In this case, we have 2 to the power of 1/5 and 2 to the power of 3/5. Again, because they have the same base, you can go ahead and just add 2/5 plus 3/5, and you're going to get 4/5. So our answer is going to be 2 to the 4/5 power. So as long as the base is the same, you can always add the exponents, and then that's going to give you a more simplified expression. So let's go over the first 3 to start off, and then we'll keep going. The first 3 is a is the same base, so I can just do 3 plus 2 to get a to the 5th power. Now 3 is just a multiple, so I'm just going to bring it down, and I can add the ends with the exponents. So it's going to be n to the 8th power. Now for number 3, I am going to multiply the numbers. So 24, okay, and then add the exponents to the 9th. Also for number 5, I know there's like a little square. Take that as a multiplication. I guess the page glitched when we downloaded the notes, at least for me. So for number 5 is a multiplication in the space of that box. So we're going to multiply the 8 and the 6, so 48. Then add the exponents, p to the 9th. This is going to be 21 times 2, so it's going to be 42d. And we have to add the fractions 1/2 plus 1/4. So this is going to become 2 over 4. So it's going to be 3 over 4. So it's going to be then negative 6.1 times 3. It's going to be negative 18.3 m to the 6th power. 7, 3, and 9. So we're going to do h. Add 10, 5, and 2. So it's going to be to the 17th power. Then we're going to multiply for number 8, negative 9 times 6 is negative 54. Then we're going to do q. Now negative 8 to 11 is going to be positive 3. Then 16 times 2 It's going to be negative 32r to the negative 6 power. Now to fully simplify this is going to be negative 32 over r to the 6. All right, so for 10, we have two variables, so we're just going to take them one step at a time. We're going to do the y's, add the 3 and the 2 to the 5th power, and we're going to do the z's, and 13 plus the negative 6. It's going to be a positive 7. Now for 11, we're going to multiply all the constants, so 3 times 5 times 4. So it's going to be negative 60 if I'm not mistaken. Now the x's I can add because we have 1x here and 1x here. So it's going to be a half plus 1/3. So that's going to become 3 over 6 plus 2 over 6. So it's going to be 5 over 6. And then we only have one w, so we'll leave the w alone. That's going to be our answer for 11. Now for 12, I'm going to do 15 times negative 8. That's going to be negative 120. And then we're going to take it one letter at a time. So the f, we have 1 plus 3, so 4, minus 1, 3. The g, we have 2 plus negative 3, so that's negative 1, plus 6, so it's going to be 5. So that's what we get for 10, 11, and 12. So for 13, we're going to combine the m's. So m, we can do negative 6 plus 3, it's going to be negative 3. And because there's no other n's, the n is just going to stay the same. Now for the next one is 6 times 7. That's going to be negative 42. So our j's, we can add them of negative 2, and our k's will become 6. Now for 13 and 14, let me simplify them fully. Remember, when it's fully simplified, there are no negative exponents. So the way you would also simplify 14, that's going to look like this. And then for 15, we're going to start, so negative 6. The u's would add up to 3. The v's will add up to negative 1. The w's would add up to 0. Now to fully simplify this, the w0 will become 1. So I'm just going to ignore it for now. It's going to give me negative 6 u3 over v. And if I multiply everything times 1, which is our w0, it's just going to be the same thing. So this would be my final answer. Now for 24 to 32, you guys are filling in the exponent that's missing based on the addition. So please go ahead and do those 9. I'll go over them in a minute. So 24, so we can add the exponents to get 13. This is supposed to be a 10. This 5 we can ignore. I don't know why it was there. So we can do 6 plus 5. It's going to be 11. What can we add to 4 to get to 10? So 6. From 11 to 2, what can we do? It's going to be negative 9. To get to 4 over 5, we can do 2 over 5. So we have 2 plus 1 is 3, so we're missing 6 to get to 9. Here we want to get to 3 times 2, so we want it to equal to positive 5. So we're going to add 10 right here. Then for this next one, this 13 is supposed to be the exponent, so it's going to be 17, and 5 is going to be negative 12. So negative 12 to get to 13, we're going to need 25 to add up to 13. This last one, we want the t to equal to negative 4. So we're going to need this one to be negative 9. And then the u's already done for us. All right, since there are no more questions, you guys do have homework. It is on Canvas. This is it for today's notes.